Now we are further continuing with the application, and for this application now I will again make a figure, and according to the figure we will discuss this question. So now our question is like this, that is, I am taking here in this figure, this is electric field. The line which is, the square is indicating electric field. E stands for electric field. There is a water drop in electric field. This is water drop. And it carries charge. This water drop carries charge equal to 1 electron charge. So we mark E here. E stands for electron charge. And the radius of the drop, that is R. So what exactly in this figure is elaborated? E is electric field, and there is a water drop. This is double shaded here. The radius of this drop is R, and E is the charge on this drop. What is the relation between R and E? So our question is relation between R and E. Like one of the relation is radius directly proportional to e to the power 1 by 3. Radius directly proportional to e to the power 1 by 3. Second one, radius directly proportional to e to the power 4 by 3. The third one, R is inversely proportional to E, and the fourth option, R will be inversely proportional to e to the power 2 by 3. These are the four options. So now you are finding here, there are four options for the question. I hope the question is clear to you. The question is of the pattern, that is, E is the electric field. This circle is indicating the water drop. R is the radius of the water drop. E is the electronic charge on the water drop. Now we have to understand that out of the four options, which is the right option for this question? Whether radius will be proportional to e to the power 1 by 3, e to the power 4 by 3, inverse to e, or 1 over e to the power 2 by 3. Now to solve this question, neither electric field is given, nor the radius is given, and electronic charge is E. You will remember, the most elementary charge in our universe is supposed to be E. E means either electronic charge or it is proton charge. You remember, electronic charge is written as like this. This is electronic charge, which is equal to E. And when we write like this, the charge is same but plus E. Proton charge, and this is also equal to E. So most elementary charge is either electron or proton charge, and we have written like this. This is called modulus. Modulus means magnitude. So magnitude of electron charge is E, and the magnitude of proton charge is also E. Whether the number is negative or the number is positive, its modulus is always positive. That is what you have to remember. And the numerical value is 1.6 10 to the power minus 19 Coulomb. This is also the same, 1.6 10 to the power minus 19 Coulomb. So it is very clear to you that which is the most that is elementary charge. The most elementary charge is 1.6 10 to the power minus 19 Coulomb, whether it is electron or it is proton. Now, to start with this question, you will remember we are going to use the concept of balanced forces. It is a water drop, and you will remember for water drop, density is D, density of water drop, that is D, and D is equal to mass by volume. This is a formula for density. So density is mass over volume, M is the mass of this water drop, V is the volume of this water drop. Now, volume of water drop means volume of sphere, because this is a sphere. So we should write that is m over 4 over 3 pi r cube. This is the formula. Density m over 4 by 3 pi r cube. What is r representing? The radius of water drop. So density will be 3m divided by 4 pi r cube. Like this, we can write the density. This is the density of water drop. Now you will further remember, here electric field, this is to be related to radius. So how to relate these two numbers? You will remember further, electric field is force by charge. This is the formula. Electric field, force by charge. Now how will you find it? You can try yourself. I'll give you just 1 minute to think of, and then you will solve. Electric field is force by charge. And density is this one. So these are the formulas to be correlated. Downward force on this drop will be mg. That is, drop is attracted towards the earth, and that is called its weight. So what is the weight of the drop? Mg. But drop is neither coming down nor going up. It means it is balanced by electric field. It is balanced by electric field. What is F? Force, Q is charge. So electric field is force by charge, or force is EQ, or force is EE. Because the charge on the drop is not Q, it should be taken as E. So upward force is electric field, and force due to electric field is EQ, and downward force, that is the weight of the drop. You will remember, weight is the force due to which bodies are attracted towards the center of earth. So, you will remember further that weight is force and force is mg. It means that drop is under the action of two forces. One of the forces is EQ or EE, and other force is F is equal to mg. Because drop is in stable condition, not going up or coming down, so EE must be equal to mg. So EE, this is equal to mg. Condition for the stable drop. M that is the mass. So EE will be mass, that is density into volume. Here, density is mass by volume. So mass is how much? Density into volume. So it is density into volume. Now EE, this is equal to density into 4/3 pi r cube g. You remember G is acceleration due to gravity. Acceleration due to gravity, and if its value is not given, it is taken as 10 meters per second square. However, its value is 9.8 meters per second square. If it is given in the question, and if it is not given, its value is 10 meters per second square. Now form the equation in terms of R, because our interest is to find R and E. So we'll make cross multiplication. 3EE divided by 4 pi dg. 4 pi dg. And this is equal to R cube. So now we are finding here R cube is 3EE over 4 pi dg. Is E constant? Small e? That is electronic charge? It is constant. Pi constant. 3.14. D is density of water. This is also constant. 1000 kilograms per meter cube. G is acceleration due to gravity, constant. How many constants are there? 3/4 constant, E, pi, D, G constants. Only variable is E. So we can say that if we multiply the exponent by 1/3, here also we will multiply by 1/3. All other numbers other than E are constant. We have not to consider them. So these three will be cancelled off, and R will be proportional to E to the power 1/3. And this is the right option. So I hope that this type of solution is clear to you. And what are the fundamentals we are using in this question? We are finding that it is not restricted to simply electrostatics, but many other concepts are used in one question. So, in the competition, examiner give a question that will be from say 3 chapters, 4 chapters, and if you solve the question, it means that you know all the 4 chapters. That's why you have solved the question. So, this is the solution to our question that if the water drop is suspended under the balance conditions, what should be its radius? If electric field is given to you, it means that drop carries charge. Wherever there is any charge on the drop, it must experience some force. Downward force is always known as weight. Weight is force due to which bodies are attracted towards the center of earth. So, weight is also force. I have written force is mg. This is a downward force. And EE, this is the upward force. And because the drop is not going up or coming down, so we have equated the two numbers and made the calculations. So radius proportional to E to the power 1/3. Thank you.